Let's have a look at the natural logarithm, or ln. Let's have a look at the graph for ln x. Here's the graph. Let's zoom out a little bit. Okay, a couple of things that are very typical for the natural logarithm, or ln, is that, let's see, if we zoom in closer here, we can see that we have a 0 at, it looks like it's 1, 0 when the x is 1 and y value is 0, but let's trace this function just to be sure. So there we have the 0. So escape, move this coordinate a little bit. So at 1, 0 we have a 0. The function is crossing the x-axis. That's one thing. And it also seems like it's getting closer and closer to the y-axis as we're going down here, but it will never touch the y-axis. So let's zoom in closer to the y-axis. If we zoom in, we see that it never touches the y-axis. So that means that if we zoom out again, this means that this function is only defined for positive x values. So ln x here, we can only choose a value for x that is greater than 0. We cannot use 0 because it will never touch the y-axis. It's not defined for x is equal to 0. Or we can see here it doesn't exist on the left side of the y-axis. So no negative x. We can just, to make sure, add a calculator page and let's try and see what happens. So first of all, ln 0, undefined. If I try to enter a negative value for x, let's see, ln minus 5, it says that it's a non-real calculation, so we could actually do it if we work with complex number, but that's not included in this course. So for us it means that ln for negative values can't be done. Let's have a look at, for example, same thing as the exponential functions. We can, for example, get some exercises where we want to know the equation for the tangent to the curve. Let's find the tangent to the curve ln x through the point 1, 0. So with geometry, points and lines, and tangent, let's use 1, 0. I'm gonna click escape to go out the draw mode, and then we can grab this end and grab this end to extend it a little bit. Let's see if we can do it. Line, there we go. So if we would like to find out the equation for this, menu, actions, coordinates and equations, and then we just click on the line and we see that the equation is y is equal to x minus 1. So the m value, or the slope, is 1 because it's 1x, but we don't have to write it out. So the slope is 1, and c value is minus 1 because it crosses the y-axis where y is minus 1. Let's plot this function just to compare the ex to ln x, and we can see the symmetry. If I just plot this line, y is equal to x, to have it as like a symmetry line in the middle, we can kind of see that this is ln x, this is x, kind of can see a symmetry here.